Hello scholars, welcome to today's class. In today's class, we are going to be dealing with the topic derived quantities. In our last class, we talked on fundamental quantities, and I made it known to us that we have 7 fundamental quantities. And out of these 7 fundamental quantities, we have 3 to be the most common fundamental quantities. Please, in case you haven't watched the video, check the video you can see on the screen, and please do well to study diligently, as everything there will help you to understand that which you are about to do in today's class. Thank you very much. What are derived quantities? From the name derived quantities are quantities that depend on fundamental quantities, or we can say that derived quantities are quantities that are being gotten from fundamental quantities. So they are being derived, they depend on fundamental quantities either by multiplication or by division. So in a simple term, we can say that derived quantities are quantities that depend on fundamental quantities by multiplication or division. So that means that derived quantities, they have formulas. For them to have been derived from fundamental quantities, they possess formulas, unlike fundamental quantities that lack formula. So these are the examples of derived quantities that we have. We have more than this, please. We have area, we have volume, we have speed, we have velocity, we have acceleration, we have force, we have density, we have momentum, we have work done, etc. So what we are about to do now is to know the formulas of each of these quantities. And once we know the formula, we are going to be able to get the units. Remember, I said in our last class that quantities, they have their units. Fundamental quantities have their units to be fundamental units. Derived quantities, they have their unit to be what? Derived units. But for us to know the units of these derived quantities, we need to know the formula. So when you have the quantity, which is derived quantity, you are going to know the formula. Knowing the formula, then you will know the units. And please, if you are preparing for the JAMB UTME examination or WAEC examination, trust me, this class, it is for you. All right. Number 1 here, we have area. So area has its formula, and the formula for area, it is said to be length times length. If you decide to use length times breadth, no problem. But in this case now, we want to stick to length. So length times length. So if this is said to be the formula for area, now ask yourself, from what we've written down, length, is length a fundamental quantity? Yes. Length is a fundamental quantity. Area has its formula to be length multiplied by length. So since length has no formula, then what is the unit of length? The unit of length is meter multiplied by meter. Remember we said the SI unit of length is meter and not centimeter. Meter multiplied by meter, that is meter squared. So this is how we got our units to be meter squared. So the unit of area, it is meter squared. Okay. So number 2 here, we have volume. Volume has its formula to be length multiplied by length multiplied by length. Please, if you want to use length multiplied by breadth multiplied by height, it is still the same thing. Because what is the unit of length? We have to be meter multiplied by meter multiplied by meter. So meter multiplied by meter multiplied by meter, and this will give us meter cube. So if you are being asked that what is the unit of volume? The unit of volume is meter cube, but how did we get meter cube? We got the meter cube from the formula. Remember we said you need to know the quantity, the formula, then from the formula you are going to get the unit. Then the third one, we have the speed. Speed has its formula to be distance over time. Distance over time. So now ask yourself, distance, is this a fundamental quantity? Yes, it is. Do not get confused. I know most of us are thinking, oh, after all the quantities given to us, fundamental quantities given to us, we do not have distance there. Yes, but distance is also a form of length. So we can say that this distance also means length. So what is the unit of distance, which is the length now? That is meter. Over what is the unit of time? That is seconds. So then we can say that the unit of distance of speed is meter per seconds. Meter per seconds. Or it can be written like this: ms raised to power minus 1. Meter per seconds. Alright. Number 4, we have velocity. The formula for velocity is displacement over time. Displacement over time. Mind you, speed and velocity, they have the same unit. We can say they have the same formula because speed and velocity, they are being used interchangeably. Velocity is displacement over time. So as you all can see, that the only difference between the speed here and then the velocity here is distance and displacement. One has distance, one has displacement. Distance and displacement, they are in form of length. Displacement too has its unit to be meter. Meter over seconds. So we can say that this is meter per seconds, or ms raised to power minus 1. Meter per seconds. I believe we are getting it. So the next one here, we have acceleration. Acceleration. Acceleration, also being a derived quantity, it has its own formula. And what is the formula for acceleration? The formula for acceleration is velocity over time. Please, you have to know these formulas. When you know this formula, knowing their units, it won't be an issue. So now, velocity over time. The question is, velocity is no longer a fundamental quantity. It has its own formula. Are you getting me now? It has its own formula. So that means you can have a quantity, just like acceleration, having its formula, and then from the formula, one of the quantities then we also have its own formula. Are you with me? So velocity over time. Velocity here has its own formula. And what is the formula? We said it is displacement over time, then divided by time. Again, velocity has its formula to be displacement over time, then divided by this time here, divided by time. Ideally, I would have just written out the unit for velocity, but I just want us to understand how we are going to have the unit for acceleration. Again, acceleration has its formula to be velocity over time. This velocity here now is a derived quantity. It has its own formula. So this is the formula: displacement over time, then divided by time. So what is the unit of displacement, meter, over unit of time is seconds, then divided by unit of time also is what? It is seconds. So I can just have over 1 here. Then this will be meter over seconds. In mathematics, division will change to multiplication. Then we're going to have multiplied by, then this will change 1 over s. Meter multiplied by 1, that is meter. Second, that's s multiplied by s, that is s squared from the law of indices. S multiplied by s will give us s squared. So that means that the unit is meter per second squared, or ms raised to power minus 2. Meter per second squared. You can also write this unit this way. So whenever you have this, just know that it indicates meter per second squared. So if you are being asked that what is the unit of acceleration, yes, it is good for you to know the units. That the unit of acceleration is meter per second squared. But in case you've forgotten the unit and you know the formula, with the formula you will know the unit. All right. So the next thing here is force. Force. Force has its own formula. And what is the formula for force? It is mass multiplied by acceleration. Please, once again, try as much as possible to master all of these formulas. When you know the formulas, like I said, knowing the units won't be an issue. Force is mass multiplied by acceleration. So now, mass, is this a derived quantity? No. It is a fundamental quantity. It has no formula. And what is the unit of mass? It is kilogram multiplied by acceleration. Now, is this a fundamental quantity? No. This is a derived quantity. That is, it is gotten from velocity and time. So it has its own formula. But I don't want to waste our time. I will just write out the units. Let's assume that we've already known the unit of acceleration to be meter per second squared. So meter over second squared. So kilogram times meter, that's kilogram meter over second squared. So this can be written like this: kilogram meter per second squared. Or you can have it this way: kilogram meter per second squared. Whenever you have per, that's when you have this minus here. Kilogram meter per second squared. Kilogram meter per second squared. Again, kilogram meter per second squared. I believe we understand.